Logic Pro 7.1 ships with a large arsenal of software instruments. These can be used for emulating real-world instruments or for creating a huge spectrum of synthesized sounds and effects. When opening up one of these synthesizers for the first time in Logic, the sheer number of controls can be a little overwhelming, but for the most part, the way a synthesizer works can be reduced to some basic processes. Understanding these will help you understand what you're looking at and to get the most out of your Logic instruments. There are a number of different synthesis methods used by the instruments included in Logic Pro. A method used by many of these is known as subtractive synthesis. In this process, we start with a sound generated by one or more oscillators. These digital oscillators can generate specific types of pitched sounds which you may recognize as the classic synthesis waveforms: sine waves, square waves, sawtooth waves, and triangle waves. The primary tone-shaping tool in subtractive synthesis is the filter, which is used to remove partials or portions of the frequency spectrum from the audio created by the oscillators. This control can be set to remain static as notes are played, or to adjust over time for each new note. The most important control on a filter is its cutoff frequency. When this is changed over time for each note played, the effect is referred to as a filter envelope. Another element of filters is the resonance control. This is simply an increase in volume of frequencies near the filter cutoff frequency. Filters can cut the part of the signal above, below, or simultaneously above and below the momentary cutoff frequency. These are referred to as low pass, high pass, and band pass filters, respectively. How drastically the cutoff occurs is referred to as a filter's slope, and this can affect the resulting sound. Gentler slopes tend to have a more natural sound, while steeper slopes yield a more distinctive sound. After processing by the filter section, audio flows into the third and final section. This is an amplifier section, or output section, and it controls the sound's final volume. Unlike the filter cutoff, a note's volume never remains static. All musical note events arise from and return to silence. The shape or contour of each note's volume as it arises and fades is called its amplitude envelope, which is one of the most fundamental defining characteristics of any sound. When we look at the interface for the ES1, we can start to break down how subtractive synthesis is represented in the interface to Logic's instruments. In the top section of the ES1, we see the sound generation area. Audio flows from left to right among the three modules within this section. On the left side, we have the sound generators, in this case 2 digital oscillators. In the middle is the filter section, and on the right we have the amplifier or output section. It is these three parts that create and shape the sound that we hear. Now, let's look at the bottom area of the ES1. This is the modulator section. These controls create the changes over time that shape or modulate the three elements in the audio chain that we've discussed. The two most common modulators are envelope generators and low-frequency oscillators. Envelope generators control the momentary value of settings discussed above, the filter's cutoff frequency and the output section volume, with a shape that is triggered every time a note is played. The envelope generator is triggered by each note event, and this is sometimes referred to as gating. It's important to understand the difference in the kinds of musical effect that you can create when using envelopes within a synthesizer as opposed to using track automation in Logic. Envelopes create contours on a per-note basis, whereas track automation can be used to create contours over entire phrases or tracks. The second type of modulator is a low-frequency oscillator, also known as an LFO. LFOs generate slowly rising and falling, pulsing or wiggling effects. These effects can then be used to modulate the parameters of a particular sound, such as filter cutoff, volume, pan, and so on. For example, in LFO, slowly modulating a sound's volume up and down is known as a tremolo effect, while the effect of slowly modulating pitch up and down is known as a vibrato effect. There are a few important considerations regarding modulators. The first is that in some cases you, the user, may be able to set up your own modulation. This means that you can select the source of modulation to affect a certain parameter within the audio signal path, referred to as the destination or target for that specific modulation. Alternatively, the connection between source and target may be hardwired in the synthesizer's design. Another consideration is that any modulation has to have its depth or amount specified by you. This tells the synthesizer how much effect the modulator will have on the target. The ultimate effect will then depend on the depth or amount of modulation, as well as the original setting of the target parameter. For example, if your filter cutoff frequency is already as high as it can go, it will be impossible for a modulator to make it go any higher, even if you specified that it should have a big effect.